All right, you got your 1M cam. The first thing that we're going to do is we're going to make a copy of the 1M cam. So go under File, go to Save As, and then you can call it 1M cam. And I'm just going to call it Fall of 25. So F25 for me. This is when I'm recording this video. I'm going to put it in my 2025 parts folder. So under Titans of CNC, I'm going to put it in my 2025 and hit save. And now we'll see it pop up right in here. Again, it changes the name. I'm going to go ahead and close these other things out real quick. Finish these sketches and close these. Working on a few other projects here that we'll kind of get rid of. And we'll get rid of this Lego piece. Okay, so here's our file. The first thing we want to do after we do a save as is we want to go in and we want to remove the chamfers that we put on these edges. And the reason why is because it's much easier to select a sharp contoured edge rather than a chamfered edge when we're doing our machining. So the easiest way is to just roll back in time, and now they're gone. So that's usually what I do is I just roll back your little timeline down here at the bottom and roll back in space. And then the other thing we want to do is make sure that our threads here are not modeled. We just want a cylinder with a JPEG basically attached to it. So if you go back into your hole and you look down here, there's the little check mark that says modeled. Make sure that's unchecked. If it's checked, it actually makes the threads. So these are actually faces on a thread. So if you're 3D printing this, that's great. Actually have physical threads, but we don't want to do that. We're going to drill and then tap that hole. So we just want that to be a cylinder. So we just uncheck the model and it's now just a smooth cylinder. So those are the two things that we need to update on our design before we get started. Go ahead and hit save. And now you're ready for the manufacturer tab. Okay, click on the design tab here and drop down to manufacturer. And now we're in the manufacturer tab. Let me just go through an overview of what we're going to be doing, and then we're going to actually get into it. The first thing we're going to do is we're going to create a setup. We need to say, okay, what are we machining this out of? What does our stock block of material look like? What are its dimensions? And then where is this model going to be in relation to that stock? Is it going to be centered in it? Is it going to be more toward the top, more toward the bottom, etc.? We need to, sometimes we pick the machine that we're going to machine on. But for the Titans of CNC, it's a generic G code. So we actually don't pick the machine on these. When we transfer it over to our 770M, which is our Tormach machine, we will actually pick that machine. So when it does its post-process code, it has some built-in things specific for that machine. And then we're going to go through a series of 2D and 3D tool paths that we're going to create. The first one that we typically do is called a face. And what it does is it basically will take a large tool and go over the top of the stock so that it's perfectly flat on the top. So that's called facing. And then we go in and we do a 3D adaptive clearing. And what this will allow us to do is take a tool and it will basically rough in the part. And we will tell it to leave some stock material behind so we can come in and do some finish passes afterwards. So the 3D adaptive will go around the outside of the part. It'll clear out this pocket in the middle. And it'll clear out this little pocket on the side. And we're using a rather large tool, so it won't do anything with the holes or the chamfers that are here. The countersink that exists for those holes. It doesn't touch any of that. It's just going to basically profile the part and clean it out so that it's within 10,000ths of the actual dimension. And then we're going to go in with a series of 2D tool paths. The first one being a contour, and that basically traces the outside of something or the inside of something. So we're going to contour along the outside of the part to clean up and get to the actual dimension. And then we're going to use a 2D pocket command, and we're going to clean up these pockets. So it's going to come down, it's going to clean up the bottom of the pocket, and then these walls, it's going to go along the walls of this pocket, and it's going to do the same thing here. It's going to clean up the bottom and clean up these walls that are here. So that's what our 2D pocket will do. And then we're going to go ahead and put a chamfer on this edge, and then on this back, like around the perimeter of this edge, and this edge right here. And then we're going to use that same chamfer end mill to then create the countersinks by spot drilling those 7 holes. Then we'll come in with a regular drill, and we'll drill the hole itself. We'll do 7 of those. And then we'll come in with a tap, and we'll tap the holes to put the threads in it. So that's the process. Like, those are the things we should be thinking about before we start a part, is what tool paths am I going to be using to create this part from just a block of aluminum or a block of wood to start with. So, and then we're going to flip it over, and we're going to do a couple operations on the bottom side to clean up what's left over that was held in the vise. So let's do our setup. So we're going to click on setup first. Everything that we do, we want to then establish as this is our normal. So for a lot of these settings that I'm going to show you today, you need to then click on this triple dot next to it and save as user default. That way, the next time you do a machining operation on a part, this is the default that pops up every time. So let me zoom in. If you want to, you can pause the video and you can look at the settings that I have, and then we'll kind of click on certain points here. So I'm going to zoom in and let you pause the video if you need to. And you can pick these settings. Again, we're milling. We're going to use the Z-axis or plane in this case, and we're going to use the X-axis. We're going to locate what those are. So we set up our datum, and then we're going to say where that datum is going to exist. We're going to use the stock box point to do that. And then these clearances are all just based on fixtures that we don't even have a fixture. So we're not selecting a fixture or anything there. Under the stock tab, we're going to add stock to all sides. And in our case, we're going to add 50 thousandths to each of these sides. So 0.05, 0.05. And then, so that added stock to the negative X and the positive X over here. And then we're going to do a negative Y and positive Y of 0.05 and 0.05. And then we're going to do a negative Z of 0.23. We'll talk about that here in a minute. And a positive of a 0.02. So you're like, what did we do here on these? And why did we pick these numbers? Well, the stock that we're using is going to be a 2-inch by 1-inch block of wood or aluminum. So this is a pretty standard size that you can buy. And then we're going to cut it to a 4.1-inch length. Our original model was 4 inches. We're going to be a 1/10 longer. So we have 50 thousandths on either side. Our model is 1.9 inches this way. So that gives us 0.05 on either side to make 2 inches. And then we have 75 or 750 thousandths. It's 0.75, 3/4 of an inch thick right here, this height. So we're going to put 20 thousandths on top. So when we face it, we're going to take off 20 thousandths. And then we need a place to grab the part with the vise. So the 230 thousandths at the bottom, this right here, is so that our jaws can grab onto the material, and our tool, when we come around and do our tool passes, don't run into the jaws of our vise. So this is pretty normal. If you put in a 3/4 inch piece of material, you can't machine it all the way around the outside like this. You would have to do, you'd have to have a bigger piece that would create like a slot channel for your tool to go around, which is okay. But if this is a standard size we can buy, and we don't have to buy extra material just to turn it into chips and scrap, that's why we do this. So these are your settings. Again, we're doing a relative size box. Set these as defaults. Boom. Set as default. You can set these all as default. And then that way, when you do this, it's like automatic. Okay. All right. I'll give you a second to do that. Actually going to save these all as default. Sorry about the jumping back and forth. I'm learning how to use this new magnify tool, and it's not super helpful, but in the classroom, it allows you to see this a little bit bigger. All right. So all I'm doing here is I'm just saving these as defaults. So it should be literally that fast. All right, let's go back to our setup tab. We didn't finish this out. We need to say what Z-axis we're going to select. I'm going to pick the top face for my Z. And then my X-axis, I'm going to select this back line here. And then I'm going to say my stock box point is going to be this corner back over here. But my X-axis, I want to point the other way. So I'm just going to click on the arrowhead and it will flip so that my positive X is going to the right. My positive Y is going back, like up. So imagine you're looking at, the top view is like this. So you want X this way, Y this way, and Z is up toward you. So this is how your setup should be. And again, just clicking on the face, clicking on this back edge that's connected to the fixed jaw is going to be on this back wall here, grabbing the stock, and then this is the movable jaw will be on the front. And then we make this stock box point, again, set that as user default, and then pick your corner up here. This is called your datum. So this is your 0, 0, 0. When we touch off our tool or our probe, we're going to touch off on this edge of the stock, this back edge of the stock, and then the top of the stock. So it's this spot right here in space. For post-process, you don't really have to do anything. Just make sure that this work coordinate system offset, you can just put as 1. It just can't be 0. Usually, if you're using a machine, it'll be a G54. Usually is your standard. But for here, as long as you just put a 1, it's good. And then we're going to say, okay. And now we've created our setup. So that's step 1, is get your setup done. All right, so first operation is going to do a 2D face. So if you click on 2D face, we're now going to select a tool. So right here at the top. And you should have already installed your Titan building block tool set. So there should be tools numbered 1 to 17. There's some skips in there. But should look something like this, maybe. And then we're going to be using tool 1, which is a 3-inch face mill. If you've not installed your tool library, you need to go to either Google Classroom or you can go to the Titans of CNC page where they go through this. But to insert it, you just right-click on the local and you go to Import Library. And then you find where you downloaded your library. So my Titan building block tool library is right here. I click on it, I hit open, it will then create a new tool library. So you notice I've got some tool libraries here for the rocket project. And then I've made some for our Tormach 8L. And you can see our 770M tool library. So I've got an Nexus Tech library. So I've got a bunch of library of parts, but we're going to be using Titan building blocks 1 and pick tool number 1. And then we're going to say select. And it will auto-populate a bunch of tools here, or settings for that particular tool. So it picks an RPM. We don't really have to change these. Some of these are pretty fast for first-time machining. So in the video, I think it slows it down, but it's not required to do that. Like 39, basically roughly 40 inches per minute is pretty quick. You might want to slow that down to 20 or 25 when you're first doing this. But again, we're not going to run this on a machine. We're just going to submit this to get certification. Okay, so there's that one. Let's go to the geometry. So it's going to do the stock contours. So it's already selected basically the stock of our part. So you can see right here, it's the outside. It's not it's the stock. So it's bigger than our model that's sitting inside of there. Heights. Again, we're going to go from the stock top because that's where we set our 0 is. The Titans use model top. I like stock top because that's where we touched off. We touched off on the stock. So we're going to go 0.4 for our clearance, 0.2 for our retract height, and then our feed height, it's going to stop 0.1 inches above the part before it feeds into the part. And then the top height is going to be the stock top at 0, and the bottom of our machining tool path is going to be at the model top, which is 20 thousandths below our 0. So if you notice our bottom right here, it's going to be at negative 0.02, which is at the model top. So these are the values. And again, I would set these as user defaults. So go in, notice how mine already pre-populated to these values. Yours might be something different. It might be like retract height or clearance height or whatever. We don't want to do that. We want to go stock top all the way. Except for this bottom, we're going to go model top because when we face it, that's the bottom of our tooling is going to be at the top of the model with no offset. So again, pause the video and then update your values there. All right, let's click on the next tab, passes. We want to change our tolerance to 4/10. So basically, I think it defaults to 4 thousandths. We want to do 4/10 of a thousand. So add an extra 0 there and set it as default. Pass extension. We're using a 3-inch diameter face mill. So we want it to extend past the part so that that face mill fully clears the part. So if you think about it, we need to clear a radius past, which would be 1.5 inches, and then plus some. So I just added a 1/10 there. So we're going to pass by 1.6 inches. The stock offset is nice. If you don't have consistent stock in terms of you're not buying a metal bar, let's say you're machining a piece of wood, and that there might be some discrepancy in some of the stock parts that you put in there. Instead of reprogramming your machine every time, you could literally just say that you have, plus or minus a 1/10 on that. And what that will do is that will add stock all the way around your part. So you can see the arrows, the red arrows there. Basically, it pretends that the stock could be bigger than what it is. So it machines to the outside of that before it gets down to the actual model. So kind of handy, especially if you're using wood that you've actually created the stock for. We're pretending it's metal, so we're going to leave that at 0. The step over is defaulted. It's like 60% of the diameter of the end mill, I believe. And then we're going to do a climbing direction. Again, you can set that as default. You can leave. All right, go to the next tab. And all these should be fairly defaulted. Now, the vertical lead-in radius, you can put as 0.1. We're going to preserve our rapid movement here. Again, you can pause the video, get these numbers. I'll zoom in here so you can see them a little bit easier. There you go. And then click on OK. And what that's going to do is it's going to create your tool path. And you can see here's our facing operation. It's going to come down. There's our radius. It's going to come across. It's going to extend all the way out and then come back up. We can simulate that with the machine. And there's our first operation. Exit our simulation, and we're good to go. All right, facing operation done. Hit save. We're ready to do now our 3D adaptive. So that's our next thing. Go to 3D adaptive clearing. We're going to select our tool. We're going to go back to our tool library. We're going to be picking tool number 3, which is our 3/8 inch end mill. We're going to hit select. There we go. Now, our geometry, we're going to basically, this is our model that we're going to be adapting around. So again, it's going to generate all these toolpaths for us, which is amazing. We don't have to manually do any of this. Literally just say, here's the model that we're going to select around. We can actually create like a machine boundary as well. We don't want it to go in certain spots if it could hit something, if we have a fixture that's holding stuff. But again, that's all advanced items. Heights, same thing, stock top, stock top. For clearance height is 0.4, retract height is going to be 0.2. The top height for our 3D adaptive is going to be the model top. And the bottom height is going to be the model top minus 760 thousandths is our offset. And what that's going to do, if you think about our model, we know, let me kind of spin it around here, is 750 thousandths. So from here to the bottom, but we want to go a little bit deeper than the actual height of the model. The reason is because when we take off the material on the bottom side, we don't want those to line up exactly right at 750, or else you might get like this thin onion layer that didn't actually get machined. It might be pretty small, but again, we don't want that to happen. So we're going to machine deeper than we need to. So when we come back and we clear off the bottom, it's got like, you're going to remove all that material and not worry about being like this really thin layer that we might not have gotten. You know, if you're off by, 0.4 of a thousandth, you'll get a sliver of metal there that's super thin. And we don't want that. So that's why we do that. We go 10 thousandths below what we're actually going to need to machine. All right, again, pause. Here's a zoomed in view of that. So you can see those values there. Okay. Next tab, passes. Okay, this is where some of these values are really machine dependent. We're going to be fairly aggressive on our optimal load here. Notice that mine is really small to start with. It was 30 thousandths. I'm going to move that to a tenth for the optimal load for, we're assuming we have a big industrial machine. So we're going to use that. Again, you can set that as default. The minimum cutting radius is going to be based on the tool, so we don't have to change that. We're going to climb mill the whole time. The maximum roughing step down, we wanted to do this all in one step. Like when it's going all the way and machining out, we wanted to do the whole thing. So we're going to go below that 760, and we basically just go, we just do a little bit more. So we're going to do 0.8, which would be 800 thou. And then we've got a fine step down if we need it. And then we're going to leave some stock where you leave 10 thousandths radial and axial. So radial and axial stock are around the edges and like the floor. So the radial is around this way and axial is up and down. So it'd be the floor of this and the floor of this pocket are going to have an extra 10 thousandths of material that we have to machine away after this step. So there's our values. Here's a look where you can pause and get all those numbers. Again, it just populates a lot of these based on the tool. And there we go. Next tab is the linking tab. Again, I'm going to let you pause the video. The major change that we're making here is our stay down level, I believe. We're going to go 70%. And then for our helical, we're going to helic down into this pocket, and we're going to use a 4-degree ramp angle here on this so that it ramps down pretty quickly to the bottom of this. And you can set that as default. You can set this as default. And it kind of shows you the different ramp types on how you get down. But the helix is really nice. I'll let you write these down so you can zoom in here. And again, most of these are based on the cutter. So because we picked a 3/8 inch end mill, it's going to give us these values. Like it's going to auto populate a lot of these values here. Okay, that's it. We're going to hit okay, and then we're going to look, and here's what we're looking for. We're looking to make sure that it goes all the way down and cleans out, all in kind of one pass all the way around. So you can see that there. So there's our contour that goes around the outside of the part. And then we're looking for the distance between these blue lines. So this is when it comes in and it's going to clear out material in the middle here. How much material is it taking out per swipe? The tighter those are together, the more movements you have to do, but the less material it takes. And the bigger the gap, the more material it takes. You can see here, it's going to clear the pocket out, but notice it leaves, see this little bit? You see the line here, but you see the extra green around it because it's leaving stock behind. So it's got stock on these edges, both inside and outside, and it has stock on the floor, which you can't really see, but there's stock here that's left as well. When we do our simulation, we can see this run. We can see how it's going to go. We should know what our toolpath is going to do in the order. So it's going to do this contour first. It's going to come in. It's going to do this little pocket out front. Clears that out. And then it's going to start the helical ramp and helical down. So if we change that from 4 degrees to 2 degrees, you'd see that the step between each of these would be half as much. So it would take twice as many spins to get to the bottom. And here's what we're looking for is how much is this actually carving out of here? And this is a pretty aggressive cut. But again, most machines can handle this pretty easily. The cool thing is we can go to statistics and it will tell us how long this will take for this operation. It'll take basically, almost 4 minutes to do this, which isn't too bad. The whole part we'll be able to do in like 10 minutes, which is pretty good. But again, that's what, as a programmer, you want to optimize and you want to get that machine time down, because if I can make an extra 2 parts an hour, like that's money I just made my company by doing this. So I'm going to change a couple settings just so you can see what happens as a result. So if I change the optimal load, so if I go back to here and I change that to 0.03 and I hit OK. So I'm going to have more lines, more of those blue lines, and you'll see it takes off less material every time it goes in and is clearing out material. So again, it's doing all this toolpath work, and you can see that. So this is very light. So on our Exostech router, like our smaller machine, this is what we're going to go with. Like we're going with really, because its spindle doesn't have very much horsepower. The tools we're using, we're not even using a 3/8 inch tool. We're using like an 1/8 inch tool. So we've got to baby that machine when we're taking off material. The 770, we can pretty much run at full, the full specs of this. Now, when we're cutting wood, when we're cutting aluminum, we do about 3/4 of that. So we kind of find a happy medium between the two. When we use our 770, we'll change that number in this optimal load. But for, again, this setup, we're going to use that 0.1 value and go with that. So that's our 3D adaptive. All right, next we're going to clean up everything. So we need to do some finishing passes. We're going to use the same tool. This time we're going to do a 2D contour. So if you think about it, we want to run the tool all the way around the perimeter of the part. So we're going to select the tool. It's already kind of said, oh, we already got tool 3 in the queue, so it's already set. We can actually drop down and see what tools we have, or we can select more of them. We are not doing machining type. We just skip that tab because if we're doing 3-axis, it defaults to that. Now we need to pick the geometry. And this is why it's important to remove those chamfers at the beginning. Because now when I look at the bottom of the part, to get the outside contour, it's literally just this line right here. There's no chamfer to worry about. I don't have to worry about if I click on the wrong line. It's just this one. It's going to go around the part. Heights, again, I do the same thing here. Stock top, 0.4, 0.2, 0.1. This is pretty much in everything. Set it as defaults. And then you need to think, okay, where's the top of my machining going to happen? And where's the bottom of my machining going to happen? So the top of my machining is going to be at the model top. And the bottom is going to be at the model top minus 760 thousandths. Now you're like, well, why did you do this? It doesn't matter. I'm just showing you another option for the bottom height. If you notice, it's still at that negative 780 because we want 20 thousandths for the facing. And then it's another 760 for this operation. So you can do either one. You can say model top and you can say negative 0.76. And look where you end up. You end up at the same spot, that negative 780 number. So as long as you are where you need to be, it doesn't matter. Now, don't do this. If you do the model bottom and now you're machining way down here, you're going to crash into something. That's bad news. You need to pay attention to these numbers. Like if you go negative 1.5 inches, you're going to run into the vise and you're going to screw something up. So whatever you do, pay attention, to what you're doing and make sure these numbers make sense and check them. Like literally look at your part from the side and say, okay, yeah, it's going to machine just below that value. Okay. I'm giving you options. All right, let's look at this tab. So here, change your tolerance to 0.4, so 0.0004. We're going to do a wear compensation type. It gives a compensation radius allowance. So again, as your tool wears, you can adjust that. We don't really deal with that a whole lot. We're not making super precision parts in our lab. You've got a finish feed rate. Again, you could slow that down to 20 inches per minute if you wanted to, but I'm going to leave it. We're going to roll around the corners. They're already filleted, so that makes it easy. We're not roughing on this. We're not doing multiple depths. We're not leaving any stock. It's just one time around. Finish. So everything else is unchecked. That looks good. Linking tab. Preserve rapid movement. Safe distance should auto-calculate. Now, here's where we're going to make some modifications for our lead in and our lead out stuff. So we're going to have a lead in radius. It's basically 1/10 of the tool. So the tool is a 3/8, which is 0.375. So 1/10 of that would be 0.0375. Our sweep angle is going to be 45 degrees. It defaults to 90. Let's change that to 45. And then again, save that as user default. Linear lead in. We'll talk about what all these do. Again, the diagrams are great and they show you what part of the swoop in we're talking about. So if you look and you kind of hover over, it's going to give you a picture and it's going to show you the distances for each one of these and what they're for. So I'm probably going to put this in the quiz. Like, what is this right here? That's the horizontal lead in radius. It's a radius, it's a curve to get you to lead into the part. The flat is the lead in, the linear lead in distance. So it's a straight line. It's linear line. And then you have a vertical lead in radius, and this is the drop down radius that's there. To kind of dive into the part. And then we're making the lead in the same as the lead out. We're not ramping. Now this is kind of cool. This says preferred lead in positions. So if I run this, because this is my last tab, by the way, I'm going to say, okay, so I can see what it does. Look where it brings the tool in. It brings it over here on the backside that you can't see. Remember, this is in the machine like this. And this tool is going to come down on the backside of the part and come in and start cutting, and you can't see it. That's usually a problem. Like we want to see that tool come in and start cutting. So here's our lead in. You can see the lead in angle here. We can see our linear lead in distance, and we can see the vertical lead in. And we can see that 45-degree angle. See this, when it touches, that's now at a 45. If it were a 90, it would come kind of straight in, which we don't want. It swoops in, which is great. But we want it to come down maybe on this side over here so we can see it. So that's a cool little feature, is I can just click on that last tab and I can say my preferred lead-in position, and then I can just select over here on this line, one of these two lines here. I usually pick the one that faces me. I'm going to click on that edge and I'm going to say, okay. And now look where it drops the tool. It's where I can see it. I can make sure it's not going to crash into anything as it comes down. Again, as you're doing these, you should go in and play with some numbers. Like, there's nothing wrong with you going in and saying, okay, what happens if I change this number here to 0.1? And I say, okay, what did that do? How did that differ from my last thing? Well, it made this radius different. Okay. And I go back in and I do another value. See, it changed my vertical lead in as well when I change that. If I change this linear lead in to 0.1, what does that do? Well, now I make a longer lead in line right here. So this distance right here, this linear lead in is now greater. So play around with these numbers as you're learning so you know what they do. I'm going to change this to 0. And I'm going to see what that does. So if you notice, it comes straight down and then it goes in. There's no radius here because it's 0. So it comes down and then it starts doing its linear lead in, and then it does the linear radius right here as it goes in, hits at 45. This is perfectly acceptable. There's nothing wrong with this right here. So you can kind of play around, modify your things, see what happens. It's all good stuff. I'm going to change this to 0.05 and say, okay, get a little bit of a radius there as I swoop in. Looks good. You can simulate it, always simulate. So you can see what's going to happen. As a result, it should now, you should see your lines. So now you're taking the stock down to the model. So we've now cut that back edge or the outside to the model dimension all the way around. Looks good. All right, that's our 2D contour. .2D pocket. That's next. 2D pocket. Here we go. Same tool. Don't have to change it. Geometry. We're going to select our two pockets, the bases. So there's the floor and there's the floor. So we're selecting those two pockets that we're going to machine. Heights. Same setup. 0.4, 0.2. Feet height here, I was 0.2. We're going to change that to 0.1. And then we're going to save that as default. I don't know why that was 0.2 for me, but there we go. Now, again, where are we machining from? We're machining from the model top. And now we're going to clear out all the stuff in here in the middle in this. So where's the bottom? Well, you could say it's how far from the model top. Anybody remember when we made our 1M? Those cut downs are how far? They're ½ an inch. So we can say -0.5. And it's going to show us where that's going to machine to. You can see right there. There it is. Or we could just say, let's go to the selected contours and do a 0 offset. Because where did we select the contour at? We went right down here. So we could just do that. Sorry, magnified the wrong way. So we could just do a 0 from the selected contours, which we selected back here in the geometry. So when I look here, that bottom height should be now at this floor right there. Click on passes. Again, the step over should automatically be calculated based on your tool, I believe. you could change it a little bit. So usually it's around 80% of your tool. So if we take 0.375 in our calculator times 0.8, that gives us 0.3. So as long as you're like 60 to 80%, you're good on that. That's the distance as it moves over to machine more material. So we can do 0.25 is good. We are not leaving any stock, so we're unchecking that. If it was checked, we don't want any stock because it's a final pass. Again, tolerance is going to be 4/10. This all looks good. This time, when we ramp, we don't have to helical down because there's no material in here anymore except the base. So we're just going to plunge straight in. So it's going to plunge straight down. And again, we're going to change these numbers to the 45 degrees. We've got, 0.0375 for our horizontal lead-in radius, the lead-in distance, and the vertical lead-in. So we'll keep all that. And then you could, again, do your preferred lead-in positions. You can say, okay, I want to lead in on this side over here. Oh, it didn't like my ramp clearance height because of this right here. So I'm going to change this to 0.05. It's got to be less than your feed height. So when you look at your feed height right here, this number plus this number has to be less than that. So this should do that. And there we go. So now it does our pocket. So you can see that it's going to plunge down. You can see the arrow here. It's going to plunge in. It's going to then swoop in. It's going to do this little thing. It's going to move over. It's going to do this. And then we're going to watch it. And it's going to come out here and it's going to do this outside and a couple passes here. So let's do a simulate and see what it does. Again, you can see the stock is still there. And then let's see what happens as we go in and we machine this out. And there we go. And there we go. And you can see that we now are to our model line. And we are now at the right heights down on the floor. That looks good. There's our 2D pocket. Now we're finished with all of this stuff. Now we're ready to drill some holes. So the first thing we're going to do is we're going to chamfer first, actually, and then we'll spot drill using the chamfer. So we're going to go to 2D chamfer, which is right here. We're going to select a tool. We're going to go to tool number 15, which is the 1/4 inch chamfer. And then we're going to hit select. We're going to leave all these numbers. Go to geometry. We're going to select the outside contour, this contour. And notice the arrow direction, they're opposite. This one goes clockwise, this one goes counterclockwise. It's because they're touching different parts of the tool. So they're touching different sides of the tool, so that's why it's moving different directions around here. If you did this, it would machine on the outside of this line, which is no good. We want to machine on the inside of the line. Same thing with this one. We want to machine on the outside of that line. It's pretty good about intuitively knowing which direction you want to go, but you just want to check it. Heights, again, same setup, 0.4, 0.2. Again, feed height, you can do 0.1 if you want. Set that as default. Model top for both. No offsets. We want everything to be right here at the top. It starts there, finishes there. It's going to be a single height at the model top. I'll let you make those adjustments. Again, here's a zoomed in view. All right, let's go to passes. Again, 4/10, roll around corners. All right, this information. This is, again, why we remove the chamfer from our model, because it makes these numbers really easy. The chamfer width is just the size of the chamfer we want. So we wanted a 10,000th chamfer. So we're just going to make our chamfer width 10,000ths, 0.010. Chamfer tip offset is how far up the chamfer tool we're moving. So if you look here at the diagram, you can see the bottom of the tool, and then we're going to cut 40 thousandths up that sidewall. This tool doesn't have a point, but we have a point on ours, so it'd be a point on our chamfer up for that. So 40 thousandths is pretty good. And then clearance, 25 thousandths, so we don't run into anything, is good. You can make that tighter. If you get more proficient at machining, you can put that down to like 5 or 10 thousandths, but for our purposes, 25 thousandths is going to keep us from running the tool into anything. Those are that particular tab. This tab. Again, preserving rapid movements, doing a safe distance of 80 thou. Horizontal lead in, we're just doing a 10 thou horizontal lead in. Doesn't take much. You could up that. You can make that 50 thousandths if you want. Again, we're doing a sweep of 45 degrees. So you can see the difference there and what that does. Again, we're coming in nice arced angle there, sweeping in at 45. And then our lead in distance, again, we've already looked at that, and our vertical lead in. Again, these numbers don't have to be, they're not too critical. Key is this perpendicular. A lot of times it's perpendicular, sometimes it's checked. And if I hit OK, I want you to see this tool path. See how this is kind of wonky? It like crosses over. See how they cross over each other, like the in and out? That's because this is perpendicular. See this angle right here? That's a 90-degree angle from when it ramps down. It does a 90 and then goes in. And that's not good. We want it to be a nice, easy swoop in. So the reason you see this is because that perpendicular button is toggled, and we don't want that. So we're just going to go back in. We're going to untoggle that perpendicular, and now look at our tool path. Nice and sweet, boom, right in there. Now, again, where is our tool coming in at? It's way over here on the back side that we can't see. So how can we adjust that? Well, if we go to that linking tab, we have preferred lead-in positions. We want to lead in here, and then we can also tell it where to lead in on this thing. So I might want to lead in right here in the middle so I can see it. And I'm going to say, okay, now take a look. So my outside chamfer leads in at this position, and my inside chamfer leads in at the position where I want it there, so I can see it. And then again, do a simulate. It should be cutting off material. So when we come down, we can actually go in and look. So I'm going to go back in time here. Let's see that. So this is a great view right here. Right here of what that 40 thousandths does. So from this tip right here to this cutting point, that's a 40 thousandths tip offset. Now, if I make it like 100 thousandths, see how it's going to cut here? So the tool is going to be further out, and less tool is going to hang into your part, which is going to come in really handy for doing this one down here, which is our next tool path. But again, we should see it cutting that chamfer. You should be able to see it just like that. 10 thousandths, just breaking that edge. As it goes around, this looks good. Comes out, does the same thing on the other side. Cool. All right, we're going to do the same thing for this little ledge right here. So I'm going to right click and duplicate that same chamfer. So I've got the same settings, and now all I have to do is 2 quick clicks. The first one is geometry. I'm going to get rid of these chains, and I'm going to select this one. So there's one quick change. The second one is the heights. I'm no longer at the top of the model. Where am I at? Well, I could just say selected contour and selected contour, because now I'm down here. at the selected contour. And the last thing I want to change is the chamfer tip offset, which I'm going to look at here in just a second. But I'm going to do this first. And you can see it comes in. I'm going to go ahead and simulate it. But you can see that it doesn't chamfer all of it. It doesn't get all the way out here. It comes down and then it cuts. Well, if we were to pause this and actually look at it when it comes down in here to cut, the reason why is because look how much of that tool is in the part. How much of that it comes in there? It's going to crash into that wall if we go any closer. So if we back this up a little bit, we don't want it to crash into this wall. So we've got a clearance already. So when we come down and we go into this spot, so the way to fix that is just change where it cuts. Instead of cutting here, we're going to cut way up here on the cutter. So my tip offset, instead of 40 thousandths, I'm going to change that value on my passes to 100 thousandths and say, okay. Now look at the line. It's maybe tough to see here, but look how far out that chamfer now comes. Because now when I play, look at how much is sticking into the part now. Barely any. Look where it's cutting on the chamfer. It's cutting way up here on the tip of that cutter, or on the edge of the cutter. It's way up here now instead of way down here. So because of that, we're able to get a little tighter into that little window. So those are the things that you can do with chamfers to get into tight spots if you need to chamfer little areas like this. I'm going to go back. I'll zoom in and let you see some of these tabs. So this is the default for the tool, so you don't really have to adjust any of those. Geometry, again, we selected this one here. Heights, same as what they were before. The only difference is we changed the selected contour, the top height, and the bottom height are now the contour that we selected down here. These should all be default. So if you made those default and you copied them, it shouldn't change. So we're just changing those two right there. And then under the passes tab, we changed our tip offset. And then we didn't do anything with linking. It stayed the same. We are so close to being done. All right, now we're going to use the same chamfer to spot these holes. So I'm going to use a drilling operation this time. I'm going to keep with the same tool. If it doesn't, you can drop down and you can pick that 1/4 inch 45-degree chamfer. Geometry, select one of the cylinders and then click the same diameter one. So see this right here? And it will pick all 7. You can see it selected all of them. This is all default. Shouldn't have to change any of that. Heights. So now we need to use our brain a little bit. Again, stock top, stock top, stock top. Feed height, we can do 0.1. Now the top height is going to be the whole top, or you could just say model top. I would probably do model top. And then the bottom height is going to be model top with an offset of -0.21 divided by 2. And you're like, where did you get that number? 0.21 divided by 2. Here's where I got that number. That number is a result of what that chamfer was, or that countersink. I'm sorry, countersink on the original model. So I'm going to go ahead and hit OK just for a moment so I can get out of the screen. And then I'm going to go back to my design tab. You don't have to do this, but I'm showing you this is how I knew that value. So when I look at this and I look at my diameter of my countersink, it's 0.21. So because this is a 90-degree angle, this is a 45, 45, 90 right triangle. So the vertical distance to the bottom of this point is the same as the radius of this circle. And what's the radius compared to the diameter? It's 1/2. So that's where I got that number. So when I go into the manufacturer tab and I pick my drilling operation for this spot, I'm literally putting in a distance of 1/2 the diameter. And when you look at it, look at your tip. See that? It should follow that line. It should be perfectly right on that spot right there. So you know you got it right if it looks like this. Like it should look like it fills in that space. All right, let's go to cycle. We're doing a drilling rapid out. It's going to be in and out. One shot. It's not drilling very much. It's a pretty small, simple hole. We're just kind of putting a little mark. And then again, we're just going to leave these, avoid collisions, preserve rapid movement. And then we're going to say, okay. And then when we simulate it, it should go around, it should then spot the holes. So it puts these little chamfered divots in your material. This allows the drill to find a center point so it doesn't walk. We kind of talked about that when you try to drill metal, it wants to walk around unless it has a little divot to ride in. So this is creating the divot and the chamfer kind of all in, or the countersink all in one. So our drill can ride in the middle of that hole as it's drilling. All right. The beautiful thing is we're going to drill with two other things that are not chamfers. We're going to drill with a regular drill, and then we're going to drill with a tap. So we're going to just copy this same thing and just duplicate it. And we're just going to change a couple settings now. So double click on that second one, and let's make some changes. The first thing we're going to do is we're going to change from the chamfer to an actual drill. So the drill we want to use is this 0.1772 drill. This drill is for a 1032. So right here, you can see 1032 is going to be, this is the tap. But this is the drill we want to use for that particular tap. It's a 0.1772. So it's tool number 10. And we're going to select OK. And you're like, how did you know that? Well, here's kind of how. If you go in and you look up tap hole drill size chart, there's a whole size chart that you can look up that machinists use to tell what size hole you need for what size tap you're going to use. So if we look over here, we're using a 1032. So see it right there? Ooh, I was wrong. We're going to use a different one. So 1032 is right here. See it? What size hole does it recommend? It recommends a 0.159 roughly. Somewhere in this range is what you want to be shooting for. Okay? So if you're doing a 1/4-20, so if I go up here to 1/4-20, I need a 0.201, which is a number 7 drill is what it's called. So if I go down here, I need a number 21 drill. See that right there? Number 21 for a 1032. So let's find that. Sorry, I'm on my magnifier and it's throwing me off. All right, here we go. So let's go back to our tool and go back to the Titan building block. And here we go. This is the one we want, 0.1601. So we're going to use this tool number 11 to actually make the holes. Our geometry stays the same. You can see all the holes here. Those look good. Our heights are going to be different. So the model top stays, but now how deep do I want to drill this? Yeah, negative 0.5. So I'm going to come in here and put a negative 0.5, and it's going to then drill down a half an inch from the top. And then the last thing I'm going to change is the cycle. So I'm going to do a deep drilling full retract. So what this is going to do is it's going to peck down and then come back up. It's going to do a pecking operation, just like we did in drilling our blanks for our pins, right? We don't do that all in one shot. We're going to do a little bit, and then we're going to chip break and let those chips come out. And then we're going to do it again. And our peck depth for this, you can do like 75 thousandths is probably good. So 0.075. And then everything else stays the same. We're not going to dwell at the bottom. Our minimum pecking is we're just going to do 75 thousandths the whole time. Hit OK. So those are the little updates we made. Doesn't take much. And again, when we simulate just that step, we should see the pecking operation of this particular drill. So here we go. Peck, 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 peck. Perfect. I don't need to watch the whole thing. That's what we wanted to do. And then the last one, we're going to right click, duplicate it again. Now we're going to tap the hole. So our tool for this one is going to be our 1032 tap. So again, we go into our building block tools. We want the 1032 right-handed tap, tool 13. Geometry is still the same. Heights, we don't want to go as deep this time. I think it told us to go like negative 0.38 at least. So we're going to go negative 0.4. We don't want to bottom out the hole with that tap. You'll break the tap off. So we want to go, basically a tenth less than the hole depth. And then the cycle, we're going to pick tapping. It's a right-handed tapping. So we do a right tapping. You guys know right-handed versus left-handed threads? So right-handed threads are normal. So when you turn it to the right, it tightens, and then lefty-loosey. Righty-tighty, lefty-loosey. Left-handed threads are reverse threaded. So for example, your bike, how do you pedal? Think about your right leg on your pedal. How are you pedaling? You're pedaling forward, right? Most of the time. So what's that going to do to the nut on that side? It would tighten it. But what is your left foot doing? It's spinning the opposite direction. So what would happen to a nut on that side? It would loosen because it's going left if you look at it. So we'd have to reverse thread that one so it doesn't loosen over time. So that's why you'd have a right-handed versus left-handed thread, something like that, where you're on one side, it's turning one way, and on the other side, it's turning the opposite. You don't want them to come apart. So we're doing a right-handed thread. We have a right-handed tap, and then no dwell, and we're just going to say okay. And then it's going to be a pretty quick, simulation here as it taps the holes. And again, our machine can't do this. Our Tormach machine can't do this. It's called rigid tapping. It synchronizes the spindle with the vertical movement as it enters into the part. And there it is. We have just machined op 1 of the 1M. All right, op 1 is done. We can rename this. Just slow double click it. We'll call it op 1. We're going to create a new setup. This setup is going to have so we're going to flip it over this way. So that little groove channel is going to be faced toward us, that little pocket there. The Z-axis is going to be here. The x-axis is going to be on the back plane there. And then we're going to use a model box point this time. And we're going to select this back here. And let me explain why we're doing a model box point on this one. The reason is because when we machine the first operation, this stock is no longer there. So when I go to the stock tab, if you go from preceding setup and hit continue rest machining, I'm just going to click on OK right now just so you can see it. It knows what it's already machined. So you can see the green. So the green is what's actually left. This yellow is not there anymore. It's been machined away. So we've already touched off on the back side of this, which was where that jaw is, that fixed jaw. So that Y point on my model, which is now touching the fixed jaw, isn't going to change. So that's kind of nice. The X side over here, I can then touch off on. And that's going to be my 0. And then my top, you're like, well, how do you touch off on that? Well, what I could do is I can measure the total height of my stock of what's left. So from this right here, all the way to the bottom here, I can measure that distance. And then when I touch off the top, I could then say how far above that 0.75 mark I really am. We'll talk more about that when we get into the machine, but this side, we're just going to put this on the model. Okay, so just trust me on this for this one. So going back to the setup, again, click on face. We're doing, again, this should be default. So we shouldn't have to do anything except click on face, click on the top, click on edge, and then click on this back edge. Make sure that the little groove cutout is facing me here, and then my arrow is pointed to the right, and the Y is pointed, up, like so. And again, stock, continue rest machining, and hit OK. All right, now we're ready to do our 2 operations. First one is a face. So do 2D face, hit your drop down. There's tool 1. It's already ready to go. We're going to take off the stock. So the stock contour is great. Heights. Again, we're doing stock top. So we're above the part. Because again, there's stock still on the bottom side here that it knows about. So that's why we're doing stock top. We're getting out of the way. The top height is going to be the top of the stock on the bottom. And then the bottom height is going to be at the model top on this one. So we're going to machine down to the model top, which is, these are our defaults. Again, notice I didn't change anything. This was all user preset. The only thing I'm going to change is right here, multiple depths. Because if I did this in one shot, like look at this. This is an aggressive maneuver here. So this is if you don't do multiple depths. Take a look at what it's going to take off in this simulation here. So here's my object. I'm going to go slow and watch what it does. Look at that. That is a big old cut. Look how much it's removing. That's, for some machines, fine, but for our machines, no, and usually not great. If you watch the Titans CNC videos, they do this kind of crazy stuff. This is not normal, okay? So we don't want to do that. We don't want to hit it in one shot. So the only thing that we're going to change is on this passes tab, we're going to hit multiple depths, and we're going to do 50,000 step downs. We're going to do a finishing step that is a 10,000 step down. And everything else stays the same. Like we didn't change any of those values. All of it was default. And we're going to hit OK. And now you're going to notice that we've got multiple step downs. You can see that we step down 50, 50, 50, 50. And then our last step down is going to be a little bitty 10 to do that. And then when we simulate it, this is much more user-friendly when it comes to the removal of material. See the difference? Look at, we're cutting off there. 50 thousandths. Here we go. Cutting off another 50. Another. So you can see this is not too bad. And then we're going to leave a little bit. Oh, you're like, what? It didn't leave a little bit. Well, remember, how much past our actual part did we cut down? We cut down an extra 10 thousandths. So if you notice, we got rid of that deck, but we're still not to our model yet. And that's what this finish pass is going to do. You can see right here, it's going to be right at the model line. See the model line right there? So when I go and I do this last pass, boom, it now cuts it down to that model line. Comes all the way through, exits out, and we're done. And then finally, 2D chamfer. Select the tool. We're using tool number 15. The geometry is we want this contour. Again, it's easy to select. We don't have the chamfer modeled, so it's just this outer contour. All the heights can stay the same. This feed height should be 0.1. We're going to the model top. Remember, this is our new model top here. This chamfer tip offset of 40 thousandths is good. Hit OK. Oh, it came right here. Oh, look here. This looks good. It's not crossing over. It comes here at the front side so I can see it. Run your simulation. Again, notice how fast this is. Once you have your default settings already set, so much quicker. So when you do that 2M, it should go fairly quickly. You should be able to do that in 30 minutes or less. And then again, once you get, a couple of these under your belt, they should move fairly quickly. Especially Op2 sides. Op2 sides you can do in like 2 minutes. And then you're done. You save it. Just say OK. Change this to Op2. And then what I want from you, you're going to turn this Fusion file into Titans. So how you do that is make sure you save it. You're going to go to File, Export, and you're going to export the Fusion 3D file. So it's an f.f3d. And you can call it 1mcam. And then this is the file that you're going to upload to the Titans of CNC. They're going to ask you some questions. They're going to ask you like what tool you used, what's the pocket depth, what's the chip break, those kind of things. 4 questions about these tool settings. And then it's going to ask you for your part. And this is the part that you want to send them. For me, I want you to click on Op1. And then I want you to do your simulate, or you can actually, I think you can just highlight. No. You can go to simulate and just take your slider for your simulate and just move it all the way to the end. And I want a screenshot of this. Okay. So I want to see this right here. I want to see all your tool paths, and it should look something like this. So you're going to do that for Op1, and then you're going to click on Op2, and you're going to do a simulate with that. And then you're going to flip it over so it's in this direction. Again, orbit around so you can see what you want. Simulate. Use your slider bar down here at the window and drag it across. And this is what I want to see right here. I want to see the multiple depths from your face, and I want to see your chamfer that's gone around the whole thing. Take a screenshot of this. So 2 screenshots. You're going to put that in your documentation for your Titan 1M cam. That's your submission for me. Submit it. Try to get your certification. Again, it probably won't come by Christmas. So that's why I want you to document this for me and get that submitted. That's what I got for you. Good job. Try the Titan 2M on your own. Like and subscribe.